Hello. Today I'll be presenting the findings of a recent experiment I participated in, which focused on one of the most important products of modern society, batteries. Before I introduce this experiment, I would first like to briefly go over the origin and purpose of batteries. Although Benjamin Franklin coined the term battery in 1784, the first battery was not invented till Alessandro Volta invented the first practical way of creating electricity. Volta's battery, fittingly named the Voltaic pile, used a zinc plate anode and a silver plate cathode. Eventually, in 1836, John Daniell designed the Daniell cell, which used a copper sulfate cathode and a zinc sulfate anode. This new design lasted much longer than Volta's pile. For the next several decades, this design was improved upon repeatedly, with Gaston's first rechargeable battery and Lewis's improved alkaline batteries being two notable achievements. Finally, the first lithium batteries invented in the 1980s, with Sony commercializing lithium batteries in 1990. Consumers use batteries to power almost all the electrical appliances, from remotes to even their security systems. Like consumers, most companies use batteries simply to power anything that is not plugged into the power grid. However, companies related to the use of renewable sources like wind, water, or sunlight will likely need to use large batteries to store electricity, since renewable sources often do not provide a constant supply of electricity. For batteries to meet these commands, batteries must last as long as possible while not overheating, since high temperatures often decrease the battery's overall efficiency. Since lithium-ion batteries and alkaline batteries are the two best known ways of storing electricity, these two types of batteries are the most used batteries currently being distributed. For consumers, batteries are designed to be as small as possible while keeping battery life to a maximum. Due to these batteries' small design, they can be found in almost every utility store and local business in the US and are commonly sold in bulk. On the other hand, large companies often use bigger and more capable batteries to power their products and appliances. The most common example of these larger batteries is car batteries, with some companies like Tesla solely relying on large batteries. Despite the convenience of these batteries, once they die, they often end up in landfills, since consumers usually throw out bad batteries into the rest of the trash. At these landfills, batteries leak toxic chemicals into the soil and groundwater, which can pose a threat to any nearby plants or animals, including humans. Since consumer batteries are lithium-ion batteries, which are inherently toxic, there is little companies can do to decrease the battery's toxicity. To determine each brand of battery's efficiency, me and my team decided to test how leaving each brand of battery in an identical piece of equipment would affect each battery's voltage. We decided to test 5 common brands of AA batteries: Duracell, Rayovac, Energizer, and Vonico, and Amazon. We chose these brands due to Duracell, Energizer, and Rayovac having around the same price, while Amazon Basics batteries were cheaper and Vonico batteries were more expensive than the other brands. This allowed us to identify whether a more expensive brand would be more efficient than a cheaper battery, while also comparing batteries in the same price range. For the equipment used to drain each battery, we decided to use 5 identical flashlights, which only used one AA battery. Starting the experiment, we measured the voltage of each battery using a multimeter, placing each battery into a flashlight. Once the flashlight were turned on, we waited 15 minutes before taking out each battery and measuring its temperature using a thermometer. After repeating the process for additional 45 minutes or 3 more recordings, we then measured the final voltage of each battery to compare how fast each brand of battery dies. Since the battery still had a high voltage after an hour, we replaced all the flashlights with new batteries and turned on the flashlights once again. This time, however, we let them run for 3.5 hours. After this amount of time, the voltage of all the batteries were much lower, which helped increase the accuracy of the results, since voltage can decrease considerably during use. After the second and final trial, we noticed that Energizer had the highest temperature out of the 5 brands, with a temperature of 88.4 degrees Fahrenheit. However, Amazon and Duracell had some of the lowest temperatures, with Amazon having a temperature of 80.9 degrees Fahrenheit and Duracell having a temperature of 82.1 degrees Fahrenheit. Moving to battery life, the brand which had the highest voltage after 3.5 hours was Vonica, while the brand with the lowest voltage was Rayovac. Overall, all 5 brands' final temperature did not increase as highly as I initially thought, with the highest recorded temperature being below 90 degrees. Also, the difference between these temperatures were only around 8 degrees, meaning the temperature of an efficient battery and an inefficient battery would be around the same. Nevertheless, the 2 brands which I consider to be only average are Amazon Basics and Duracell. For Duracell, it's scored around average in price, temperature, and final voltage. For Amazon Basics, it's scored near the lowest end in final voltage. However, it was the cheapest option, so this was to be expected. On the other hand, Rayovac was undoubtedly the worst brand, since it was more expensive than Amazon Basics but had a higher temperature and a lower final voltage. The best brand was harder to identify since the 2 best brands of batteries differed considerably in price. So the best brand of battery, if not considering the price, is Vonica, since it had a much higher initial and final voltage than any other brand. The best brand for its price would have to be Energizer, since, despite its higher temperature, had the second highest final voltage. To end this presentation, I would like to explain how in the future I believe diverse types of batteries will emerge for different uses. For example, consumers might stick with lithium and alkaline batteries, while car companies might switch to a different, more expensive type of battery, which works best at larger scales. This can already be observed in a large underground radioactive containment facility, which is planned to run on a brand new type of battery that works best at high extreme temperatures. Thank you for giving me your attention throughout this video. If you have any questions, feel free to post them in the comment section.